Hello, welcome back to Blender Sushi Live Coding. Today we're gonna take a look at animation nodes version 2.1 and especially on the vector noise and all kind of noise nodes that we can use. Basically, Jack Lux and Omar, they also released 2.8, animation nodes 2.1 for Blender 2.8. I tried to install this, but it doesn't work on my Mac OS. Maybe there's like a GPU shader error, but I will be using 2.1 on the older Blender for Blender 2.79, so don't get those mixed up. And when you are installing Animation Nodes 2.1, make sure you are using the correct Python. 3.7 should be for Mac OS here, I don't know, but I'll just be using this one. Okay, so I got this installed already. This is again Blender 2.79, not the latest, but this one has the right Python to work with for animation nodes to work. So save as. This is AN demo 2.1. So I will be deleting everything. I will be using just an icosphere. Create new node 3. Let's do the usual stuff, but I'll be looking at vector noise and noise falloff. Vector noise falloff. Okay. Vector noise. This one, I thought it was generating vector, but it's actually generating float. So if we have like some kind of grid, I will be using distribute matrices. If I plug the matrices here, it's gonna give you the translation vector, but this will give you a bunch of numbers, and this can be used for displacement actually. So maybe I'll start with that, something simpler. So matrix distribute matrix output and instancer. We're gonna get this object. Matrices goes, this is get the length, okay, and this goes to the matrix. So for each object's instance being generated, just distribute it based on this matrices, which is just like a transform value on top of, yeah, this is already correctly created. We just want to kind of push it around. So matrix math, maybe just do it like this. It's gonna refuse. Okay, it's refusing. Combine matrices. Maybe this will work. Oh, it doesn't work either. Okay, this is a single value. Okay, combine vector. Combine vector. Oh, by the way, in order to see this value, you use the viewer. Okay, so that's a kind of like a single value. And the idea, actually, we don't need to have this kind of matrices, but let me try separate vector. So I will get a vector from this guy, from here. Okay, that works. This goes in there. So the x and the y is the same as the grid, but the z is coming from the vector noise. Okay, that's the idea. We don't need this crazy combined matrices, matrix math. Compose matrix, plug this in there, and this goes in there. All right, I think we are seeing something. Yep, that's our instance objects being arranged inside some kind of noise. So 100 objects, let's try this. Okay, maybe let's move this around. Okay, by default, it's simplex noise. I can increase the amplitude. if you see a lot of lines, that's the typical animation nodes. It's parenting all the instance objects, so everything is tidy, but you don't want to see the parenting, right? You don't want to see the relationship lines. So type U hide relationship lines. If you are new to animation nodes, you need to do that. It's also over here, relationship lines. All right, so we don't need to see the grid. Again, this is our master objects. This is all our instance, 100 objects being generated on the fly. If your computer starts to make noise, turn off always. Just do that. And okay, amplitude, frequency. Okay, frequency, just leave it as it is for now. Normally, you want to play around with the offset here. So compose combine vector and just use a frame here, like that. If that's too fast, float math. Usually that does the job. In the past, I will be using vector wiggle. This one is really handy. It's almost like noise. It has evolution, but vector noise will give you more. So not just simplex. You have Perlin, for example. Oh, there's a value, or what is value? White noise. It's looking different again. Cubic. I never really use something like that, but let's try with more objects. Oh, too many. Okay, let's try Perlin again. Simplex. Cellular. Oh, cell, that's cell. Okay, white noise. Okay, cellular is probably interesting one. So that's with a vector noise kind of business, and then it looks complex, but not really. We are just generating a float value and then piping it into the z value. So the xy coming from the distribute matrices. Okay, so that should be pretty clear. I'll save this. So let's do something that's slightly different. So instead of doing it like this, I will use offset. So offset matrices, of course, is very powerful in animation nodes. Let me stop this. So distribute matrices, let's get rid of the noise here. Let's go back to the original matrices and translate. Okay, it's 12, 16. Okay, so that's the default, right? Nothing too fancy. Now we want to use offset matrices. Let's just play around with the locations. Just move it up, for example. We don't even need a z divisions for now. Plug this into that guy. This is the matrices. Okay, this is an offset with noise. It's gonna translate based on the fall off. It is actually, that's pretty simple, but the offset, we have a lot of offset. That's not what we want. We want a fall off. Okay, and we have a lot of fall off, including noise fall off. That's the one that's interesting for me for now. In order to refresh what's fall off is, we can use constant, for example, and also use a delay. Delay is actually the clearest to tell you what's going on. So we have delay, fall off, and then if we animate, nothing happening because we don't have time. Plug this in. Let's move this 5, okay, by 5. Okay, that's delay. Basically, we are delaying the transition from A to B based on this offset matrices. So original position will be at 0, 0, 0, and then we're moving it up to 0, 0, 5 for each objects. So we are offsetting it. So that's kind of similar to commotion add-on. And if you are using, if you are setting this up using proximity effector, okay. So that's delay, but we can mix it up if you want. Mix, fall off. This is also something that's interesting I want to talk about, but for now, just use noise. So it's already pretty noisy. And yes, you start to see this is so much simpler in a way because we are kind of simply offsetting the matrix or offsetting the transform. This is like original position, and this is kind of the target position. So the offset or the fall off is gonna be like switching all the positions, kind of being disturbed by the noise. That's kind of how I think of it. If you're it's probably easier if we look at it using viewer. See, you can't really see the fall off. But the fall off itself is really nothing too complicated. Basically, it's just like if you have like a noise or a vector noise here, and you plug in the vector value here, which is the grid, and you use this as a fall off, it's kind of similar. But this is clearer because we can see the value. So for each of these objects, I think the fall off is a value that's between 0 and 1. You can't really see it, but I think this custom fall off might actually normalize the value of all of this to become something between 0 and 1. Maybe I'm just kind of guessing, but so that's what's going on. So if we are using combine vector, plug into this, frame goes into the X, we have noise. Too strong, maybe again, math, float math, okay. Goes into the vector offset, okay. Still too fast. Okay, Octave giving you more or less detail. Simplex, Perlin, all the usual stuff, but it's kind of like just disturbing it. Cellular, white noise. I think Perlin's okay. It's pretty good. And a part of just disturbing it in z-axis, of course, you can play around with scaling, for example. There you go. Slightly more interesting. And you can use 3D, of course. 1, 2, 3. So 4 times. Okay, this is too many. 300. Maybe make this 4 by 4 or 5 by 5 by 5. Okay, so that's definitely more manageable. Okay, that's pretty interesting. Oops. It's only got like moving ups and downs. It's nothing really particularly exciting. Although with the translation, you can also use like random vector and the size based on this, generate random value, scale it up. So now it's a little bit more, it's a bit crazier. You can also use vector noise, of course, but the thing with a vector noise, I was expecting this to generate a vector instead of another value. Maybe there's an option here. Fractal, okay. Yeah, that's interesting. That's more interesting. And rotation, I think we don't care too much about it. So yeah, I guess that's pretty much it. Maybe you can kind of randomize the color as well. I wonder if I should do that or not. Since we're already here, why not? Okay, so switch to cycles. Let's do something crazy. New cycles materials. That's for everybody here, for the instance. You're gonna make some kind of like a Christmas light emission. For the color, we're gonna use attributes, and we're gonna use call. The col, the color, will be for every single object over here. So for our object instancer, we're gonna be using a deep, I think copy full object or deep copy, but maybe just copy full objects. So each one of these will have call. If we use the call, okay, call, or what is it called, vertex color, set vertex color. So for each object, I will be using loop, tab W, loop through objects. So for each object, generate some kind of random color, and the color is coming from combine color, and we will be using the hue, so maybe random hue, the seed coming from the index, this one, okay, just leave it as it is. So if everything works correctly, we should be seeing some random color. So we are not seeing random color yet. Maybe I did something wrong. Deep copy, yeah, deep copy, okay. So this is the master, it's doing nothing. This is all the instance objects, it's doing all this crazy motion. They are all emitter, by the way. So if you're using another objects, this guy should be emitting color. Some Christmas light there. So yeah, get back to this. Now we added another complexity or complications to our setup. Even though it's not too bad, we only have a single cycles material in which the color coming in, right? If you want to do something a little bit crazier, you can kind of make it blinking. Oh, how do you gonna make it blinking? For example, you can make like a random on and off value, I guess. So similar to this, we're gonna let me think. just float math, and then maybe ceiling or floor divisions. No, maybe snap should be it. If we create random value, right, it's gonna snap into that value, and the result we can just plug it into the value. Yeah, that's gonna create a blink. Snap actually will work. There's another one that's not snap. Wow, totally forgot how to do this. Floor round. Okay, round. Round will also do the job. Number value. Oh, it's exactly the same result. But that's gonna create blinking. And if you add a frame into the calculation, just add it, create a blinking crazy light there. Yeah, now it's getting pretty complicated. Still not too bad. It's just a bunch of points, instance, object. But the cool thing is that, of course, you can increase the number and everything will still work. Okay, so that's really offset with noise. We are offsetting the transform position of each instance, but the color, etc., is coming from this setup, just random number. In fact, if you actually not using random number, you can use a vector. Yeah, this will work as well as a value for our color. But should I do that, or this is already pretty complex? So I just gonna leave it there, I think. But vector noise also can be used for color generation. So currently it's blinking because it's random number. Okay, so there you go. That's really a quick look at Animation Notes 2.1. It has noise basically, and you can do all this sort of crazy stuff. Hopefully you enjoyed this. Let me know what you think, and I'll see you next time. Thank you. Bye.